From calendars and clocks to tapes and thermometers, we use numbers in our daily lives. Let's talk about such numbers. Let's first discuss on types of numbers. Suppose you want to count the number of students present in a classroom. You count them as 1, 2, 3, 4, 5 and so on. Such type of counting numbers is called natural numbers and it is denoted as n, where n equals set of 1, 2, 3, 4 etc. Here the smallest natural number is 1, and since the counting extends to infinity, the largest natural number cannot be defined, that is, it's indefinite. Now let's go back to the classroom. If no students are present, then the number is 0. And if we include the 0 with the natural numbers, we get whole numbers, which is denoted as W, where W equals set of 0, 1, 2, 3, etc. So the smallest whole number is 0 and the largest whole number is indefinite. Suppose in the classroom there are 20 students and 5 of them left for lunch. Then we are left with 20 minus 5 equals 15 students. So that there are 5 students less in the classroom, or we can say it as minus 5. And if we include such negative numbers to the set of whole numbers, we get integers, which is denoted as Z. And Z equals set of minus 3, minus 2, minus 1, 0, 1, 2, 3, etc. So, the smallest and the largest integers are indefinite. Now that we know these three types of numbers, let's represent them in a Venn diagram. That is, in a collection of natural numbers, if we include 0, then we get whole numbers. And with them, if we include negative of the natural numbers, we get integers. Before talking about the next type of numbers, let's discuss what a number line is. A number line is used to represent numbers on a line. Consider a thermometer. It has positive numbers, 0, and negative numbers. A number line is similar to this. Considering only integers, we can draw a line showing integers with unit distance between them. Also, we can say that from 0, which is neither positive nor negative, if we move towards right, then they are positive integers, and if we move towards left, they are negative integers. This is an integer number line. What about marking numbers other than integers on this number line? Now, let's go to the next type of numbers, which is rational numbers. Rational numbers can be written as a ratio form P by Q, where P and Q are integers and Q not equal to 0. For example, 5 by 4, minus 2 by 3, 1 by 2 and so on. They are denoted as Q. Also, every integer is a rational number. How can we prove that? Consider the number 5. 5 can also be written as 5 by 1. Here, P equals 5 and Q equals 1. Both are integers and Q not equal to 0. Now let's see another example. Consider the number 16 by 24. If we simplify this, we get 2 by 3. That is, 2 and 3 are co-primes, meaning that there are no common factors between them other than 1. Since all these P by Q forms are equal to each other, they are called as equivalent rational numbers or equivalent fractions. To locate a rational number on the number line, it must be in its simplified form. So, to locate 16 by 24, we can locate 2 by 3 on the number line. For that, mark 0 on the number line. And since 2 by 3 is positive, move towards right and mark another point A. As the denominator is 3, divide the distance into 3 parts. So, it will be 1 by 3, 2 by 3 and 3 by 3, which is equal to 1. And thus, the point P is 2 by 3 or 16 by 24, which is between 0 and 1 on the number line. Similarly, we can find many rational numbers between any two integers, and that is by using two methods. Let's see an example. Find 6 rational numbers between 3 and 4. For any two numbers r and s, to find a rational number between them, we need to just find the average, which is r plus s whole divided by 2. So between 3 and 4, we can write it as 3 plus 4 whole divided by 2, which is 7 by 2. Next, we can find a rational number between 3 and 7 by 2. We get 13 by 4. Then between 7 by 2 and 4, we get 15 by 4. Now that we have found 3 rational numbers between 3 and 4, in a similar manner, we can get 3 more rational numbers like 27 by 8, 29 by 8 and 31 by 8. Now let's find them in another method. Convert the integers 3 and 4 as rational numbers, that is by writing 1 as its denominator. Since we need to find 6 rational numbers, we need to multiply the numerator and denominator by 6 plus 1, which is equal to 7. So 3 by 1 becomes 3 into 7 by 1 into 7, which is equal to 21 by 7, and 4 by 1 becomes 4 into 7 by 1 into 7, which is equal to 28 by 7. So now it is easy to find 6 rational numbers between 21 by 7 and 28 by 7, that is 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7 and 27 by 7. You can see that 23 by 7 is between 22 by 7 and 24 by 7. Here we notice that we have found a rational number between two rational numbers. So by using the same methods, we can find as many rational numbers between any two rational numbers. So generally, we can say that there are infinitely many rational numbers between any two rational numbers. Also, we can conclude that rational numbers consist of integers, whole numbers and natural numbers.